This is the required practical on the AQA GCSE for rates of reaction. So the reaction, what we're going to react here is this stuff is called sodium thiosulphate. And when you add acid to that, some hydrochloric acid, you get a solid produced, you get sulphur produced. Right, let's just balance that equation. So you've got two sodiums on the left, so I'm going to have to put a 2 in front of the NaCl, and that means we're going to need two chlorines there, so I need 2 in front of the HCl, and then everything else is balanced, so you check. Right, so the reason why this reaction is quite easy to follow, the course of it, is because it produces sulfur, and that makes it, that's a solid, and it makes it go cloudy. So what we do is, each time you do an experiment, so you're going to use different concentrations of thiosulphate. We're investigating the effect of concentration on the rate of reaction. So we've got our thiosulphate in there. I'll just call it thio. And to start the reaction, we're going to add 10 centimeters cubed of hydrochloric acid. Concentration of that, probably 2 mole per decimeter cubed. Right, and that is going to go in there to start the reaction. Now what happens is, during the course of the reaction, as sulfur is produced, it goes progressively cloudier, and what you do is you usually get a cross, and you put a disappearing cross experiment, because you put a cross on a piece of paper underneath the flask, and then you look down through the solution at the cross, and you stop the stop clock when you can know when it's sufficiently cloudy that you can't see the cross anymore. Then you say the reaction has finished. So that's how we're going to carry out the reaction. So let's think about variables of this reaction. So the independent variable, the one I'm changing, that is going to be the concentration of the thiosulphate. Okay, so we're going to have different concentrations of that and see how long it takes to go cloudy. And what's the dependent? Well, that is the time taken for the reaction, time for the cross to disappear. Okay, let's think about control variables then for this. Right, control variables. Now, there are quite a lot of different ones. Some of them are more important than others. And it's a pretty common question to ask, what are the control variables for this experiment? Well, you can say things about, like, you know, it should be the same cross and the same person looking at it, which is true. But the more important things, really, I think, is, right, we're adding hydrochloric acid every time. So we should add the same amount of hydrochloric acid, the same volume of HCl, and the same concentration of HCl each time. It's better to say things like same volume rather than same amount, because you're being a bit more precise there. Okay, another thing that should be important is the volume of the thio solution, thiosulphate, should be the same. Why should it be the same? Well, you've got to look down through it, and, you know, if it's a very, you know, you want the same depth of solution. It wouldn't be fair if one of them was like twice as big a volume, so it's, you're looking through twice as much solution. The cross would obscure more quickly. Another reason why it's important to keep the volume of the thio the same is because you're adding the same volume of HCl. So you want this, because that will give you the same final concentration of the HCl. So it wouldn't be fair if you added 10 centimeters cubed of HCl to 50 centimeters cubed of one thio solution, then 60 of another, because you would be changing the concentration of the HCl as well. So they're the most important things. Also, with any rates of reaction experiment, when you're not investigating temperature, you must keep the temperature the same. But the temperature probably is going to be the same. It's not a very exothermic reaction or endothermic. Temperature doesn't change much during the course of the reaction. Okay, so that is the independent, the dependent, and the control variables to this experiment. And another thing, safety-wise, is this reaction makes SO2 gas, okay, which is very soluble in water, but SO2 is you can't pour it down. Is a poisonous gas, and so you shouldn't throw it down the sink, because it will stay in the sink traps and make SO2 in the room. So that should go into dispose of as an alkali, and that will neutralize the SO2. Okay, so let's look at the results, okay, and how we do the experiment. Okay, so we have the table down here. Right, so you're doing 6 different runs of the experiment, and you are changing the thio concentration, here's the thiosulphate, by adding different volumes of thiosulphate and different volumes of water. And if you check the final volume in every case, the total volume in every case is always 40 centimeters cubed. So that was important to make it a fair test. Okay, and you're going to add to that 10 centimeters cubed of HCl every time to start the reaction. Right, so the concentration, the final concentration of the thio, then for this one, you're just adding, well, it's 0.2, and you're not diluting it at all, so that's going to be 0.2. For this one, where you've added half 20 and 20, you've added half thio solution and half water, that's going to be obviously 0.1, it's going to be half of that. This one's going to be in between, that's going to be 0.15, that's going to be 0.1, 0.175, that's going to be 0.125, and so on. Okay, now the results we got, just put some results here. So this took 35 seconds, the fastest one. As it's becoming more dilute, it takes longer. That was 40, 46, 56, 73, and 95 seconds. Right, that's the time for the reaction. It's not the rate of reaction. So how do we work out the rate of reaction in green there? Well, rate is inversely proportional. Is inversely proportional to the time. Because if you have a very fast rate, the time taken to reaction is going to be very short. If you have a very small rate, very slow rate, the time taken for it to go cloudy will be long. So it's inversely proportional. So what we can do is, when we work out the rate, we can just do 1. We can say that rate is equal to 1 divided by the time taken. So the first one would be 1 over 35. Okay, now that's going to give us 0.0287. And what most people do is, because that gives you lots of decimals, you can say that rate is equal to 1,000 over time, and it just makes the numbers more manageable. So that one is going to be that one would be 28. Right, so the rate of reaction there would be 28.5. Let's call that 29. Okay, this slowest one here would be 1,000 divided by 95. The rate there for that one is 10.5. Okay, and then you could do it for all the other ones. That's how you work out the rate of reaction. And you probably want to plot a graph of the rate of reaction versus the concentration of the thio. And you can plot this line through the origin, 0, because you know the rate of reaction when you've got no thio, when the concentration of thio is 0, will be 0, and you should end up with a straight line. Okay, so that is the required practical. Most important thing to realize, that to understand there, is the things you're doing to make it a fair test, to make it so that you're only changing the thio concentration and you're not changing anything else, like the concentration of the acid or the depth of the solution or anything.